Good morning, everyone, and thank you for registering for this webinar. My name is Nastasia. I'm a geospatial consultant with Geodata Design, and I'll be presenting this morning. Please note that a recording of the webinar will be available to everyone who registered. The agenda for this webinar is as follows. I will start this session by answering, what is Prometeo? We will then take a look at why the solution works. This will be followed by industry examples and a use case demo. Finally, I will close off with a question and answer session. Let's begin. What is Prometeo? The name Prometeo was inspired by the name Prometheus, meaning forethought. Prometheus was a Greek titan that defied the gods by stealing fire and giving it to humanity. This act enabled progress, making Prometheus known for his intelligence and a champion of mankind. In the same context, the Prometeo Index is a custom proprietary algorithm that produces fire susceptibility ratings, which organizations can use to protect their people and assets. This is done by removing or mitigating the risk of fires from their areas of interest. Fire poses a challenge not only to the safety of people, but also to important assets and infrastructure. Knowing this, Geodata Design created the Prometeo Index. Let's take a look at why it works. There are three main reasons why Prometeo works. Number one, it uses rich content from satellite imagery and climatic data. Number two, sophisticated and proprietary algorithms are used to produce and process data and identify high fire risk areas. Number three, the deliverables are customized to the user's needs, whether it be simple visualization or presented in an automated and dynamic application. Let's discuss the rich content. The Prometeo Index considers various factors affecting the impact of vegetation fire hazards, such as vegetation dryness. This would be the moisture content and quantity of live or dead vegetation. Remote sensing techniques were used to map and model vegetation conditions and its changes over time. Data from Sentinel-2A and Sentinel-2B is used to map and understand vegetation conditions of the area of interest. Other data sources from Airbus and Digital Globe can be used based on the data frequency and availability too. Changes in weather influence fire spread and intensity. These changes include temperature, relative humidity, wind speed, and precipitation. Availability of combustibles. Long-term drought in the dry season. Drought conditions like the one recently experienced in the Western Cape allows fires to burn over vast areas of land. Sophisticated and proprietary algorithms is number two. Using Python scripting and spatial modeling techniques inside Erdus Imagine, we fused the rich content and created a vegetation fire susceptibility rating map. But how did we know that the results we were getting were right? Well, once our outputs were created, extensive field visits were done to assess the results of the index. We concluded that a 90% confidence interval was achieved, and the results could be used to create the Prometeo deliverables. What are the deliverables? What you get is based on the user's requirement. Standard deliverables are as follows: a continuous satellite-based monitoring system, a fire risk identification layer. Additional value-added services can be added to create a full solution, such as workflow management, dynamic reporting, and a mobile and desktop app. Let's see where Prometeo can be used in different industries. Some examples include environmental, agriculture, and forestry. The monitoring of important crops ecosystems and important natural resources like forests can be done using this. The solution can aid in environmental impact assessments and is also useful in the implementation of proactive and mitigating measures. Another industry would be disaster risk management. Prometeo aids in the improvement of disaster contingency plans and is useful for creating improved fire prevention strategies. It can also be integrated to improve the efficiency of emergency services. In addition, any organizations that work with important infrastructure and even servitudes would benefit from the Prometeo Index. For example, industries such as transport, energy, and government departments such as spatial planning. With fire probability identification within corridors or servitudes, you can determine how infrastructure will be affected. It aids in task force planning and is also a useful tool for strategic planning. Let's take a use case demo. So what do we know so far? The Prometeo Index produces an information layer relating to the fire probability in an area. This layer can be developed across various systems, whether the need of the user is simply fire probability visualization, or the requirement is to integrate it into the full enterprise solution. For this demonstration, I will be showing the full enterprise solution. This is currently being implemented as part of an integrated workforce management system for managing vegetation clearing and infrastructure within a servitude. This is mainly to limit the effect of wildfires on important infrastructure. The layer is deployed into the M.App Enterprise platform from Hexagon Geospatial. This platform allows for the integration of workflows for different roles within an organization. In this demonstration, there are three main roles. The first is the manager, who will use the fire susceptibility layer to identify high-risk areas and assign inspection or clearing units to the supervisor. Then you have the supervisor, who's responsible for assigning field teams to the units created by the manager and then to report back to the manager. And then you have your field crew, who is responsible for the inspection or the clearing of vegetation within their assigned units and report back to the supervisor. I'd like to take note that by using satellite imagery, users can access and monitor vastly separated areas. This means that limited resources, such as your field crew, can be assigned efficiently to areas from a central location. Let's see this in action. The Servitude Manager logs onto the system using a secure user password to access the risk profile along his servitude. Soon after logging in, the manager can see the application. Once the manager application has been launched, they can see the risk profile within their servitude as indicated by the Prometeo Index layer. They can pan along the profile line to identify areas indicated as high risk. These are highlighted in red. By displaying the work order assignment polygons, the manager will be able to allocate work to a supervisor. The legend on the right shows him the status of each work order unit. The work order units are styled based on their status so that the units that have not been allocated can easily be identified. Once the manager has identified an area requiring clearing, they will open the manager job list. A unit is selected to be allocated to a supervisor. The work order details for the unit is filled out. These details include the priority for the job as either high, medium, or low, the type of job to be done as either inspection or clearing. The manager can also enter additional information or instructions to the supervisor. The due date when the job must be finished by can be filled in, and the job is assigned to a specific supervisor. The manager is responsible for multiple supervisors, all of which can be managed by this single application. If we reload the map, we can see that the job set up for the inspection to the supervisor is now highlighted in blue. I will log out as the manager and log in as the supervisor. The supervisor will display all units that are assigned to him. By clicking on the Action Set icon, he can view all the jobs assigned to him. When the supervisor is ready to assign the task to the field crew, they simply click on the job and this reveals the information related to the task and the notes from the manager. Supervisors will be able to provide an expected start date for the job and assign the job to a specific field team or worker. They will also add any additional instructions for the field crew to take note of. The specific field team is also assigned here. Clicking Save updates the job details. And now I will log in as a representative of the field crew team. The field crew can now view the jobs that have been assigned to them by the supervisor and prioritize those of high importance. They can open the assigned form and indicate the date that they arrived on site in order to start the job. They will be able to provide the work order status and any additional field notes. Once a job has been completed, the field worker will finish the task and fill in the completed date. The field crew also have a mobile app which they will use to report on their tasks while they're in the field. They will confirm the vegetation type to be removed and the task status. The inspection date is confirmed and pictures are taken while on site as proof and can be uploaded for supervisors and managers to view. The job is saved and the supervisors are updated immediately of the task completion. Included in this solution is a dynamic reporting tool. This tool can be accessed by the manager and helps him to keep track of work being done in his particular region by making use of a dashboard. The dashboard is completely customizable and it's depending on the user requirement. On the left, we have charts relating to work to be done, priority rating, job status, due date search, and a job confirmation chart. One can easily filter through these charts to create customized reports that can be accessed quickly and conveniently. For example, if the manager is interested in viewing units of high priority and in progress, he simply clicks on the chart and the dashboard is updated. By giving the user this customized dashboard, it gives them instant information that can be used to make time-critical decisions. As demonstrated, Prometeo is used as an early warning system and as a source of information for associated areas. As previously mentioned, the Prometeo Index produces an information layer relating to the fire probability. This layer can be deployed across various systems, whether the need of the user is simply a fire probability visualization tool, or the requirement is to integrate it into the full enterprise system as demonstrated.
Thank you very much to everyone watching this webinar, whether it be live or the recording. I will now be opening the Q&A session. With me, I have Nisbet Chimboza. He is a trainer and support consultant here at GDD, and he will be answering any questions you may have. Please type your questions in the chat box and we'll be happy to answer. So there's a question whether this will be a hosted service. Nisbet is going to answer that for me.
Thanks for the question, dude. Okay, so the service can either be hosted on your premises or we can host it on our premises, depending on the solution that you take. If you just want the data set on its own, just the Prometeo layer, to just be a layer that you get and you can host it on the premises. If you want the whole M.App enterprise solution, we can either host it on our site or we can host it on your premises as well. So yeah, it can be hosted either on premises or off-site as well.
So we have a question asking about the frequency of image collection.
Okay, yes. So in this case, we're using Sentinel-2 data for the monitoring, and it comes after every 5 days. So basically, we have 2 images within an interval of 10 days over a period of time, and we build a baseline on that imagery to basically do the mapping. Yeah, and we can always update on a regular basis. So the interval is 5 to 10 days of imagery. And also, Nadia, you can also, depending on data source that you go for, if you go for a high resolution data set from Airbus and Digital Globe, we also get regular intervals, 2 days to 3 days as well. So that basically increases the frequency. So the frequency on its own is dependent on the data source that you're using for the mapping.
Okay, so we have a question about planning to incorporate this as a real-time fire monitoring solution.
Okay, thanks for that question as well. There are already systems that are being implemented for real-time fire monitoring, right? But what ours does is gives you a probability of vegetation burning. And obviously incorporating that information into real-time monitoring add more value. So it's something that we're actually working on now to basically try and borrow data sets from other platforms that are doing real-time fire monitoring. So it's something that is in the pipeline as well for that Prometeo Index solution. I also like to note something regarding the frequency of data, the earlier question that we had. It's also dependent on the cloud cover conditions. So if you have cloud covers, you cannot really promise that you're going to get imagery for that area because you can't make up the data, right? So if the skies are clear, then you get an imagery at that time. So that's one other limitation with that as well.
Okay, so it's also been mentioned that proximity fires add another variability to burn probability too.
Yes, I agree with you there. It does add another probability to fires, but obviously it's proximity to things like roads, human settlements, and all those factors are also included, are taken into consideration inside the index as well. So we have already considered all those things like elevation, slope and aspect, distance from roads, human settlements. So we've included all those variables in coming up with that probability.
So we have 4 minutes left of this meeting. So if anyone has any more questions, please send them through now so that we can answer. Otherwise, you can direct questions to the email that you see on your right-hand side of the screen, or you can also give us a call. So it's also been added to have the ability to produce automated exception reporting for new areas that enter into high risk. So Nisbet's going to answer that now.
Yeah. Okay, that's an interesting, the way you're building up on that. So if we're to go back on the actual model that's built up, we have a baseline of monitoring that we do have. And then from that baseline, we build, we have sensitive thresholds that we apply. That basically tells us that an area is now entering into risk mode or risk area or risk probability value, and then we highlight that. The moment that either trees get cut or there's a fire burn scar there, that means the risk lowers down. When it starts recovering again, you see that it starts coming up again up until it gets into the higher probabilities. So yes, there is that continued monitoring or automated monitoring, because the monitoring is regular. So after every 5 days, you get an updated image, right? So basically after that, it's quite sensitive, as you can.
Thank you to everyone who's asked questions. If you do have any more, please send them through via email or give us a call. And I'd just like to thank everyone for joining this webinar and to everyone who is listening to the recording. Have a lovely day further.